All right, so graphing linear functions is what we're really focusing on, but it's really linear equations, which we already talked about. So the relationship that we investigated in the previous activity can be represented by the equation y equals 1.5x, where x is the time and y represents the total amount of rain. The graph of the relationship is a line, so the equation itself is called a linear equation, but since there is exactly one value for y, one output for each input, for each x, the relationship is a linear function. So remember, there is always on functions, whenever you see the word functions, you have one unique output per input. That's just the way it works. When you plug in a number, you get out another number, and it's only one number, and that's it. So let's do example number 1. It says the temperature at dawn was 8 degrees Fahrenheit, and it increased steadily 2 degrees every hour. So when they say steadily 2 degrees every hour, what do you think that is?
A linear.
It's linear, but what does the 2 represent? Constant rate of change. And what's another word for constant rate of change? Slope. Good. You guys are, oh man, you guys are doing great. So this is the slope. By the way, it says it was 8 degrees Fahrenheit. Isn't that an initial condition?
Yep.
It's initial because when they started measuring this stuff, the temperature was initially 8 degrees. What did Mr. Adams say initial conditions are? Well, initial conditions occur when x equals 0. And what else occurs when x equals 0? The y-intercept. So just in that one sentence alone, we can figure out that the slope m is 2 and the y-intercept is positive 8, or the equation is y equals 2x plus 8. And that gives you the temperature of a y after x hours. So when we go to do this, basically what they're saying is they're asking us to compare the relationship between the time and the temperature. Is it proportional or non-proportional? So in order for it to be non-proportional, what does that, let me back up. In order for it to be proportional, what do we know? What's the one thing we got to figure out? What's the difference between proportional and non-proportional? So let's start there. Proportional, what's the y-intercept on a proportional linear equation? What's b equal? 0. So that occurs when x equals 0. So when I see that x equals 0 and I plug that into the equation and I get 8, is it linear? Is it proportional or non-proportional? Well, when b equals 0, proportional ones go through the origin. And the origin goes through the point 0, 0. So this is non-proportional. But another thing you could do is you can graph the ordered pairs. So if we graph those points, they went through and they did all the math. Oh, that's gross. Get a Kleenex. Oh. You guys, let's focus on this. I'm recording. So it says graph the ordered pairs. Yes. Is this going through the origin? No. So write this down. The y-intercept does not go through the origin. So it's non-proportional. So now it says, state whether this relationship y equals point x is proportional or non-proportional. What's the y-intercept? No, this is a totally different equation. I think he told him to say hi to me or somebody, he's on the phone with somebody. Anyways, pay attention. We're trying to finish this problem regardless of the distractions. So y equals 0.5x, right? What if I think in terms of y equals mx plus b equals 0, right? So that means it goes through the origin, doesn't it?
Yep.
So from there, I'm going to go up 0.5 and over 1. Up 5 over 1. So I can just say, well, what is 0.5 evaluated at 10? What's half of 10? 5. So when x equals 10, y equals 5. So if I go all the way over here to 10, I'm going to go up 5. So it's 1, 2, 3, 4, 5. So they're counting by twos. So that is the graph of y equals 0.5x. And this point right here is 10, 5. So this is proportional because it goes through the origin. Okay. Well, it's kind of hard to draw on these tablets. By the way, I have rulers if you guys want rulers when you're graphing these. All right, we've got one more question. Can I move on to the question, or do you need a chance to? All right, so let's move on. Oh, I guess I don't have the question, so guess what? We're done with that one.